Hi, I'm Sara Golemon. I'm going to be talking about PHP extensions today. I'm going to go really fast because there's a lot of content and there's only 45 minutes to do it in. If you have questions though, do just go ahead and throw them up. We can deal with them when we get there. Otherwise, I'm going to not waste time and I'm going to go ahead and get started. Here's a quick overview of what we're going to talk about. Just going to cover some of the basics, throw pieces in, start building things up like a recipe, and we'll just touch on a few of the sort of high-level things about extension writing. So before you can actually start building an extension, which you may want to do because you have some custom library that you want to wrap, or you have some bit of code that you want to just wrap really tightly and run really fast, so you want to write it in native C code. Before you do any of that, you're going to actually have to put together an environment to do that with. Some of these things are the really easy stuff, like I need GCC, make, libtool, autocomp, things like that. Really basic stuff. The one thing that you're going to need specifically for PHP is PHP development headers and a special build of PHP that allows you to catch things that you won't catch with a normal build. For those development headers, you can usually get those straight out of a distribution package. You might apt-get installed, PHP devel, whatever it happens to be. But that's still not going to give you the debug build, which technically is optional, but again, I really recommend that you compile with these two extra options, enable debug and enable maintainer's ETS. Those will ensure that as you build, it's warning you, hey, this might work for your environment, but it's not going to work in Apache 2 threaded, or it might work on a single request, but you're going to be leaking memory and you'll run out very quickly and you'll have to restart your server every 5 hours, and nobody wants to do that. So to get your environment set up, just run configure like you normally would on PHP, throw all your other options on there with libxml, with PDO, whatever else, and just toss those two on there, build it up, you'll be all set. Here's sort of a really basic extension. This extension does one thing. It exposes a function called hello, and that function says hello world. Everybody's favorite contrived example, right? Let's look at some of the pieces that are in here. This module entry, this is how PHP knows what your extension is going to do. This is sort of the starting point. And this little macro down here, this is sort of cookie cutter. This tells Zend how to find your module so that PHP knows what to do with it. We get a list of function entries, one entry per function that you're going to expose, and I'll show this list kind of grow over time. That function table is going to point at your actual function implementations. We've got macros everywhere so that you don't have to define out, what would it be, void zif underscore hello, and then a whole bunch of parameters that mean nothing to you. And some basic header glue and a configuration file over there. This config file is your general autocomp M4 syntax. Anything that you do in autocomp you can do here. But of course, there are some specific macros that are for PHP development only, such as new extension. This is saying, hey, I want an extension called hello. Here's the files it needs to build, in this case, just one. And I'm going to enable that through the switch, enable hello. Building it is like building any other pickle extension, right? We go to our module directory, PHPIs, that's going to take your config M4, build a configure script out of it. Configure, that's going to run that configure script to create the make files. Make, got your module, load it up with PHP. The -n means don't load my usual PHP INI because we don't want to get confused by other modules doing things. Override the module directory to where it got built, load it up, and run it. Yay, we've got an extension, and it only took a couple of minutes to actually do. Have a nice day. No. Obviously, we need to do some more things with these extensions. Accepting parameters is kind of a funky thing. We don't modify the prototype to the function. We have a standard prototype for all PHP functions. What we do is we go into the stack and we say pull those arguments off the stack and parse them into specific types for what we want to do. In this case, we're giving the hello function a single parameter called name. That's going to be a string, and we're going to load it into this char and int that we pass in by reference. And then from there, it's just a normal C variable. We can say, hello, Bob. I've also added one more thing to this function entry down here, this hello arg info.
This references more macros. This is for reflection. If you want to ask the extension what sort of functions it has, you can say --rf function name, and it'll list out all the functions with their parameters. Handy little thing. It only knows what those parameters are if you define them up here in this structure. And I'm going to knock my laptop off of the podium here. Now, I used S in that example. There are a couple other types that you can pull off the parameter stack. Ultimately, every single one of these types is just this one down here. It's called a Zval or Zval if you prefer. This is sort of the unifying type for all data in PHP. All these other types are just going to say, hey, make sure it's the right underlying type, such as an int or a bool or whatever. If not, try to convert it if you're allowed to, and then drop it into the appropriate C structure. I'm not going to belabor all of these. The uses of them should hopefully be pretty obvious off the bat. If not, you can raise your hand and ask about them at this point. Let's use a few of those. So we're going to extend our example a little bit further. Now, instead of just asking for a string, we're asking for a required string and then an optional string. And that's what this pipe parameter means. I didn't go over that in detail there. We have 3 modifiers to these type specifiers. Pipe can only occur once. It means everything to the left is required, everything to the right is optional. If you don't pass one that's optional, the original C type variable is left untouched. So in this example, the second string is optional, so we have to give it a default value. If I don't pass something for the second value, such as in these, this default value is going to be left alone, and that's what we'll have when we get down to actually using it. Of course, if you do pass something, then it is there. Similarly, we can add this bang onto our type specifier. That allows us to actually do pass the value, but pass it as null. And then it'll still have the same effect as not passing the value. It'll leave it whatever the default is. User space can't do this, you might notice. There is a proposal up for 5.6 to allow default parameters, but that hasn't been accepted, so don't look for it. One other modifier, and that is the /. This one gets a little tricky. So let's pretend this / isn't here at the moment, and we're running this code. We're pulling a string off the stack, storing it in a name. We're going to print out just hello by itself. And we're going to write out the string, and we've also got the stir2 upper line in here, right? What the PHP stir2 upper function does is it won't actually allocate a new string. It'll just overwrite the string that we pass in, moving all the characters to uppercase or lowercase if that's the one you're calling. The trouble with that is that without this, whatever the user passed in is going to get modified because we don't actually copy the value as it's coming in, and there's no copy on write protection once you're inside C space. By saying /, we're saying separate this value. That is, make a full copy of it so that we can do whatever the hell we want to its internals, and it's going to get thrown away at the end of the function, so it's not going to affect user space. There are some other ways to actually solve that problem, some that are slightly more effective, but this is definitely the easiest. If you're going to change a value, separate it first. Handling variables by reference is a slightly different thing that I'm not going to cover because we don't have enough time for it, but you're welcome to ask me about it. So this sort of throws all those things together and tosses in arrays for good measure. We're going to separate our string because we're going to potentially fold the case if our array has this shout variable set to a truth value. And we've got a boolean at the end, just hello or goodbye. Again, we're defaulting it since it's after the pipe. I hope that's mostly understandable. Obviously, the array stuff is a little bit more complicated. I'll look at those a tiny bit more later on. And how am I for time? Good. All right, so I mentioned the z-value. This is what the z-value looks like inside. You don't need to know this. This is just sort of for your personal interest, so you know what's going on. All z-values have a type associated with them, and depending on what the type is, they're going to have some value relevant to that type. If it's null, obviously the value doesn't matter. If it's bool, we're actually going to store it in this long as a 0 or a 1.
Longs are longs, obviously. Doubles are doubles, strings are strings. Arrays are stored in this thing called a hash table. Objects, guess where they go? And the other two elements there are ref count and isref. Are functions variables? Well, yes, they can be if they're closures, but what a closure really is an object that has a call method on it. So where they effectively wind up is in obj. And the question, in case anyone missed it, is where do functions go? Back that up. So ref count and isref. So you're familiar from user space of taking variables by reference and taking variables by value, right? Got the ampersand in there? Technically, every variable in PHP is a reference of some kind. What we have are copy and write reference sets when this isref value is 0, and full reference sets, which are what you think of when you say references, when this value is 1. But even in copy and write sets, we can have the ref count go up to maybe 10 because 10 variables are all sharing the same value that will only get replaced when you write to it. Don't worry too much about that right now. For 80% of your extension writing applications, you don't even need to think about references. So let's say you've got a zval. You haven't asked Zen parse parameters to actually turn this into a C type for you. You're just going to take PHP Z value. How do you actually access it? Well, you got this handy macro that I didn't put up here. It's on the later side, I'm sure, called Z type. This allows you to examine what the type of that Z value is. It's like simply dereferencing it and looking at the type element. But because PHP likes to do everything in macros, you're encouraged to use a Z type macro. If I've got an immediate Z value, I would say Z type of the, check it if it's a string or array, as I did somewhere, I'm sure. I thought I had, maybe I didn't. Oh well. Use that Z type to examine what the type is, and then use any of these Z strval, dval, lval, bval, whatever macros to actually get at the underlying thing. This is great for readability. You don't have to follow these arrows down multiple paths to find out what it is. And it's also good for consistency between versions, because occasionally the meanings of these things do change a little bit, particularly as it relates to objects. The macros in this form will take an immediate zval. If you throw an underscore p on it, as I've shown on the left, that'll take a pointer to a zval, or pp is a pointer to a zval. There are cases where you'll have pointers to zvals. We don't have that many p's. So here's an example of actually using some of those. We've used our ztype p macro to analyze what thing we've gotten out of the parameter stack, depending on what that is. This is a null, so it's nothing. This is a Boolean, so we're going to say true or false. It's a long, so we're going to put out its long value, et cetera, et cetera. I've avoided getting too deep into how you deal with arrays, resources, and objects just yet. I'm not even going to touch resources because they're ancient and should die anyway. They should die because actually PHP 5 objects are resources on steroids anyway, so they're the better way to go. Let's take a quick look at variable arguments. You may have remembered this modifier from an earlier slide. Right about there. The star and the plus indicate variable argument lists in sort of a regex style. Star means I can take any number of parameters, but I don't have to get any. Plus is I can take any number of parameters, but I have to get at least one. And this was the 4 pointers to zvals I was talking about. If you do use this, you're going to pass in a reference to a zval star 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 and a reference to an int that'll basically give you your argc, argv of parameters. So where was our example? Here's our example. So I've asked for a bool. That goes in my Zen bool here. I've asked for var args. That's going to go into names and names count. And what am I doing? I'm looping through names all the way up to names count -1, essentially. This gets a little bit magic here. Because this array has been passed in, and I only want strings, well, I've got no guarantee that what's in the array is a string to begin with. So again, I have to separate these values out and make copies of them. The way I'm doing that in my own code is I'm saying, copy this zval to that zval. These sort of map out to here. So here's one of my zvals. It's the ith part of the array, which will be a zval star star. And I dereference that to go to zval star. I'm saying copy that into this temporary variable and don't destruct the original. Then convert that temporary variable to a string. I can output it, and then I kill that temporary variable. Oh, and of course, I have to free the list of variable arguments because that was allocated for me when I called then parse parameters. So there are two types of memory in PHP extensions. One is the memory you all know and love from writing C programs. Those come from malloc. This is memory you allocate, and it doesn't get freed until the program dies or you explicitly free it. This doesn't work very well for PHP's notion of shared nothing. In order to make sure that all memory gets freed at the end of a request, PHP actually asks you to use its own set of allocator functions which come from a separate memory pool. And if you forget to deallocate something, if you forget to clean up after yourself, it's just going to dump it on the floor. And it's going to say, OK, just forget it. Free that memory. It may not have been cleaned up freely, but sorry, it may not have been freed cleanly, but at least it's freed. And I'm not going to run out of memory during the course of my process. All you really need to know is, if you're allocating memory that is only supposed to live for the length of your request, toss an E onto the beginning of your malloc function. That's this whole slide. Is just say, use an E. And I don't mean the drug. Drugs are bad, except the good ones. And especially the great ones. So, writing zvals. You saw a hint of one of these macros already, this zval underscore whatever. That actually means write into a zval star some value. Again, we've got our scalars. These should be pretty straightforward. Put an integer into the zval and set its type. Put a double into the zval, set its type, yada yada. There are some more, what's a good example? I didn't list zval. Why didn't I not do that? Well, zval, as you saw, takes four things: the zval you're writing into, the zval you're writing from, and then two Boolean flags, whether you want it to be a copy and whether you want to destruct the original value. Usually you want to copy. The only reason you might not want to copy is because you just need to let some other zval take ownership of underlying data, which is kind of an odd case. And usually you don't want to destruct unless you're explicitly taking away one reference to that variable as you separate it out. This just takes a quick look at dealing with writing to arrays. These are completely different looking functions than the macros we have up here, because PHP is all about consistency, right? Initialize an empty array. This is like saying $A equals array. Put things into it. This should hopefully be pretty straightforward. The T down here is going to be your various types: null, long, double, string, string L, et cetera, et cetera, et cetera. If you want to make nested arrays, you can just create a second zval that has your nested array and use add assoc zval or add next index zval or whatever to put that inside. The bottom left table there is about dealing with references and reference counting. I'm not going to go into those in detail except to say that they exist. Getting into how references work is a much deeper topic that we can probably talk over a beer, and I'll give you more information that you want to know. By the way, beer, not cider. I had a bad experience with cider last night. But the party was great, right? So how do these actually translate into returning values from functions? Well, as part of that prototype that we get from this macro, there's a parameter that comes into your function, which is a zval star. That zval star is actually where your result value goes when you compute it and store it. So what we've done here is we've used this function return long a plus b. This is saying, well, here's my value that I want to return. Here's the type that it is. And the return macro is actually a wrapper around retval long return. Retval long is then a wrapper around zval long specifying the return value. These are just contrivances. They're just to make your code a little bit more readable. Use whichever feels right to you.
Returning strings, you have one extra thing to think about, and that is copying of the value. If you're like returning a constant string, you just had double quote, foo, end quote, well, that string doesn't belong to the engine. That belongs to the process space. So you don't want the engine eventually freeing that when the Zval is no longer used. How do you solve that? Well, you just tell the engine never to free the underlying string values. Well, you can't do that because sometimes you actually need to create strings dynamically, such as not seen on this slide. But sometimes you do want the engine to clean up after you. The solution is to let the engine always clean up after you. And for constant strings, you would use this one parameter to say, automatically make a copy of this. It'll do an E stirred up on it, which is just like a stirred up, but for engine memory. Bottom line, if you emalloc it yourself and it only belongs to the variable that you're returning, use 0, otherwise use 1. And if you get the wrong one, then Fry will come out and say, leak detected, fix it, fix it, fix it. Oh, here's an example. I knew I had this in here. PHP's got its own special SP printf function. This works just like SN printf or sprintf, except it takes a pointer to a car star, and it'll actually emalloc that for you to just the right size to fit your string, and then copy it into that location. Because this has now been emallocked, we're going to pass 0 onto return string because the engine can now take ownership of that. We don't need to copy it. And I actually feel like I'm going too fast, so if people have questions, we can definitely fit those in there. I was so worried I was going to run out of time. Let's look at populating some arrays. I sort of described this verbally. This is a visual slide, so you can actually make sense of it. Array in it, again, this is just like $ret equals array. Add to a specific string index, add to a specific numeric index, add to the next available numeric index, add to an associative index, on and on. PHP arrays will do the same thing internally that they do in user space. Since this is a numeric string, it'll actually translate that to a numeric string for you. Sorry, into a numeric value for you. And then we just add some more things to it. We've got a subarray here for Spanish language greetings. We're essentially saying, here's a new array, throw some things into it, and then pop that on, or push that onto the return array. Pretty straightforward, I hope. So examining arrays, is a bit uglier. Instead of having nice intended for PHP arrays semantics around it, the array examination functions are all built around the Zend hash table, which is the underlying function, underlying implementation of an array, but it's also the underlying implementation of the class table, the function table, the whole bunch of module list. Everything that's in the Zend engine lives inside of a hash table. So it's much more generic, and the structures wind up looking a bit uglier. We have to do things like casting our Zval star star stars to void star stars in order to make them fit into the variable type correctly. It's kind of ugly, but at the end of the day, you have these basic set of examination functions. You can find out if particular keys exist in an array, or indexes, if you say Zend hash index exists. You can pull them out of arrays using find. There it is. Again, this is for associative. There's Zend hash index find for numerically indexed arrays. For variable arrays, they're always going to come out as Zval star stars, which of course the Pascal reference becomes Zval star star star. And what else have I done with it here? I said as long as it exists, say that it exists. As long as it's a string, put out its value, otherwise just say not a string. Straightforward. So that's basic extensions. Questions so far, because we're going to switch gears a little bit. All right, I've made all your eyes glass over. That's where we want to be. The questions, again, can wait until we've got the beers later on. So that module entry structure, that sort of
start of all things PHP extensions. Again, this points at our functions. We've got a whole bunch of other pointers here that we can fill in with interesting things. These first, well, okay, technically 5, but really 4 of these represent life cycles of the PHP runtime. I've got another slide that shows it a little bit more in detail, but the idea is we have one sort of initial module init point where this is the first time the module has any chance to do any sort of initialization. This is your big startup. This is when you call your sub-libraries, you know, to build their tables, whatever they have to do. You can take extra time in this because this is only a one-time thing. It's only on server startup. Then we've got request init. This is running every single page request. You want to keep these as lean as possible because they're being run whether or not your extension's even being used in that page request. But occasionally, sometimes you have to do some things in there. You have to null out a value. You have to reset a count or whatever. And what can you do in these things? This is module init that this slide is looking at. This is where you're going to declare your constants. You only need to do that once. Declare your INI settings. Only need to do that once. Define resource types. Only need to do that once. Declare classes and deal with any specific callbacks. Most extensions do not register system level callbacks. These are for things like APC. It'll grab the compile hook and insert itself into that chain. Request, init, and shutdown. Like I said, these are for every single page request. Little stuff goes in here. The filter extension uses this to grab all the page request data that comes in, throw it into its internal values, and then shove the HTML encoded versions of it in to get whatever it happens to be doing. Session extension will use the post request cleanup time to actually do the save, write things to disk. This is why you can have auto-saving extensions. So auto-saving sessions, rather. But there's more. I glossed over module info. This is just what comes out of PHP info. I'm not going to talk about that. That's all that needs to be said. Using these sort of EX versions of these sort of filler macros, we can get access to a few extra pieces that can be put in here. These were introduced in 5.1, and these were introduced in 5.2. So if you're writing extensions for very, very old versions of PHP, bear in mind you either can't use those or you need to put some if-def checks in to make sure that they're not going to be used when they can't be. Ignore this INI entries. It doesn't effing work. Dependencies is good for making sure that your extension loads up at the right time. As an example, if somebody writes a opcode optimizer, that wants to get loaded before APC so that it can do the optimizations on the opcodes before APC actually stores them in shared memory. So it's going to say, I have a reverse dependency on APC because I have to run before APC. Optional reverse dependency is what it would be. Other examples might be PDO. The PDO MySQL driver is going to have a direct dependency on PDO because, well, the functions aren't going to be in the process space until PDO loads. So it has to load first. Stuff at the bottom. I almost dread going into this because of the amount of time that we have, but global variables. This is not a PHP script. This is not isolated to just your page request. Global variables within CSpace means that every single extension and bit of the runtime is going to be fighting over the same data space, and multiple requests are going to be fighting over the same data space as well. Fortunately, Zen's got a layer in it called TSRM, it's a thread safe resource manager, that will allow you to define sort of globals that are in their own little buckets per thread. So if you've got 2 requests that are processing at the exact same time in the same process space because it's a multi-threaded web server, you're not going to have both of them trying to write to the same global variable at the same time because they each have their own per thread copy of it. This is where you define what the size of that structure is, what that structure looks like, how to initialize it, and how to shut it down at the start and the end of each thread. Don't look at post request shutdown. That was bodged in for one particular internal extension. There's really not a lot of good reason for using it. It has to do with processing after objects have been forced to destruct. Just ignore it there. So this is kind of what the right life cycle looks like. We get one eminent, one M shutdown. All they happen, except in Apache 1. So in Apache 1.3, we actually get an eminent M shutdown, eminent cycle at the beginning. It's just the way Apache works. Try to ignore it. Every time a thread starts up, we get this G in it. Every time the thread shuts down, we get a G shutdown, which I did a copy-paste error there. I'm going to fix that. This is G shutdown at the bottom. And this is R shutdown. More copy-paste problems. We really like initializing. For each page request, that's our block of 3 here. We are in it, we go into our runtime, and then we are shut down. Fix that slide. Nobody mentioned that at FOSDEM, by the way. I had the same slide up, and nobody even mentioned that. So thread globals, looking at those again. You know, if you're in a single threaded application, you kind of don't care about this. You can ignore all this extra stuff, and you just say, well, I've got a global, and I'm going to access it. And I don't care. I do what I want. But because PHP might get loaded into a threaded environment, you might be using it in Apache 2 Worker, we need to have these structures defined here. Again, macros, because PHP loves macros. This is going to define Zend hello globals as a structure with all the things that you want to use as per thread globals. We're going to have specialized accessor macros so we can actually get to those within our script. In a non-threaded environment, we just declare this once. In the real global scope, we access the values, and it's nice and quick and easy. In a threaded context, we go through a deeper chain. This macro expands to a gigantic pointer hell. I've got an example of it on my blog if you want to see what that looks like. It's ugly. But again, we initialize it at thread startup. We don't actually have a need to shut it down because none of these things are really doing anything special. Maybe libdata's got to shut down. You might need to call that. I don't know. And then we're using them up here using our custom macro, which is going to grab the counter element out of the structure. So this is essentially giving you access to this long on a per thread basis. And within that thread, we're just incrementing this each time that function is called. Really exciting, I know. Oh, INI settings. These are old INI settings. These are PHP 4 INI settings. These are nice and easy to do. Here's the name of my setting. Here's its default value. Here's when it's allowed to be changed. And ignore that. Accessing it, though, is ugly. Because what are we doing here? We're saying, give me a Boolean from this INI setting. Well, how's it going to do that? It's going to look up the string version of that INI setting and convert that to a Boolean value on every single invocation. Do you really want to cast a string to a Boolean every time you look at this? Probably not. We're saying this can be set anytime you want, and it should write itself into the polite variable inside the Zend hello global structure. Now, we're going to access that using that thread macro that we had before. So instead of pulling out a string from a hash table and then converting that to a Boolean, we're just going to look straight into here, which, again, on a non-threaded environment, is literally just looking in the process space. It's a single pointer lookup. Much more efficient, although a little bit harder to understand the first time. We also get the advantage that if you set hello.polite to foobar, it's going to complain and it's going to say that is a meaningless, irrelevant value for this, so don't do that. Declaring constants could not be simpler. One line, done, moving on. I do have one example in there that got introduced at 5.3 for namespaces. Obviously, you specify the namespace you want it to go in. Now we're done. Important thing about constants is that they can only be truly, well, I won't even say that. They can only be PHP's definition of scalar values. That is to say, a long, a double, or a string. Weirdly, there's no macro for Booleans. There's a way to do that. Look for some examples of that elsewhere in the code base. It's kind of ugly. I don't know why nobody's gotten around to actually adding that macro yet. Complain to any of the core devs in the room that you happen to come across. Don't complain to me. Because I don't want to hear it.
So objects and classes are next. We've only got like 15 minutes left, 10? Yeah, so no hands are coming up, screw questions. Here's our basic class definition. Again, could not be harder, could not be simpler. Freudian slip. We throw this into our minute because we're just going to do it right when the module starts up. We only need to declare the class once. And we say, here's a name, register it, done. Doing it with a namespace just means wrapping that name in a little macro. All that macro really does is turn that into a string that says, hello, /1. That's all that macro actually does, which /1 means single \1. Declaring methods is going to look very familiar because this looks just like how we declared functions in the global scope. We're going to have this Zen function entry, exact same structure, attached to our class definition. And we're going to have PHP MEs in here now instead of PHP FEs. Only difference between these is that an ME is going to accept the name of the class that it goes with, and it's going to give a spot for visibility. Zen access public, Zen access private, Zen access protected, which can be piped with CTOR, DTOR, static, and a few other options. And here's an example of that. We've got a constructor named construct as it should be, and actually flagged explicitly as a CTOR constructor. The arg info is the same arg info you saw in functions. There's no difference with those, so I'm not going to cover them again. Magic methods work exactly the same. Get is just a function. It's just a regular public function. No need to do anything special with it. Destruct gets marked as a detour. And in this example, we're defining sthrough as a static function, so we've piped that onto there. Declaring properties. Anyone in this room should be able to look at that and know exactly what's going on. So I won't belabor the point. Again, we have spots for visibility, static or not, blah, blah, blah. What was this slide about? Oh, this is an actual method implementation. Obviously, if we're going to declare them using those PHP MEs, we also have to declare them using PHP method. Again, works exactly the same as PHP function, but we now have a spot to put the class name in there. Fun fact. The class name that you use in PHP ME and PHP method don't actually have to be the class's real name, as long as they match each other. It's probably bad practice to set them to Holy Hand Grenade of Antioch, mostly because it's going to be a lot to type, and also because it's going to confuse you when you look at the code in 5 years. But they don't actually have to match, just random bit of trivia. So once we're in a method, how do we get at this? We get this. I know, that's hard, right? Get this is going to be a Zval. It's just going to be the actual object's Zval to work with. And I'm sorry for slipping between different pronunciations of that. Can update a prop. Pretty straightforward stuff. I'm sorry, cameraman, for jumping back and forth like that. I don't even think I want to go into custom objects right now, just because the amount of time we have isn't there. Again, we can save this for the beer tap. They get really complicated. They get really, really complicated. If you want to see how complicated they get, look at the source for RunKit. Coming back to the config M4, we eventually want to link libraries in, because most of what PHP extensions are means to get from user space into library code. So how do we link a library? Well, here's an example. This comes actually straight out of the zlib config M4, which is a bit more complicated than this. I compressed it down a bit. What are we saying? We're saying, well, we're going to use the PHP arg with macro instead of the PHP arg enable macro. These two macros are actually effectively identical. The only difference is one uses the word enable, one uses the word with. By convention, we use enable for extensions that don't depend on external libraries, and with for extensions that do. But that's just convention. We've got a list of places we expect to find the hello library under user local or user. If you pass -- with hello equals opt, for example, that is going to go into your $PHP hello variable. And that's why we've got it on this line here. We can effectively now search user local, user, and opt. In practice, you probably should have this at the front, since that's where the user set it is. But I didn't really think about that when I was writing the slide. The way we check to see if it's there, we're just going to look for its header.
because if we've got its header, we probably have its library as well. Cross your fingers. Store that into another local variable. If that variable never got set, get to the user an error that says, I don't have my library. If they did set it, just make sure the library is there. Link it in if it is. Add its include directory. And then here's our new extension. Sorry, our new extension was up here. Pretty easy to follow, I hope. We can use check library to find out what symbols are actually exposed by it. This is important if you're dependent on a particular version of a library. There are multiple versions of libz, for example, or zlib, sorry. There are multiple versions of zlib. Some of them have gz init, some have gz init and gz init 2. So you might look to see if that gz init 2 is in that library. If it is, you know you've got a recent enough version. Other things you can do is you can do an AC try run that's familiar from all configure scripts and output the value of a particular header defined. That may be another way to find out what version you're dealing with. Did you raise your hand? Oh, 5 minutes, okay. That's okay, we're just about done. Here's an example of AC try run. All I'm doing here is I'm saying val is of type howdy value. Well, that's not a useful program, but it is useful for determining if we have this howdy value struct type def. If it is, this will build and run fine. If it's not type def, we're going to get a build error, and that's going to lead us into this third case. So we can say, where's our checking? Up here, checking for type defs in howdy h. If it succeeded, then we say, hooray, and we move right along by defining this so that we can use it in our program. Otherwise, we say, crap, we don't have that type def. Let's just not define this thing and move on, and we'll just build without support for that. Windows. Does anyone in here use Windows? Sorry. Does anyone here use Windows for PHP? And I don't mean your editor. Yeah. Theoretically, it's a relevant operating system, so I include this slide. That's what they tell me. I don't know. What am I using? Oh yeah, that's a Mac. This is all vaguely JavaScript based, so the syntax is going to be familiar enough to use. And we've designed the support within this framework to look as much like what AutoConf uses. So you're going to have the same sort of functions. Check header add include matches up to check header add include. Imagine that. Although we have extension instead of PHP new extension. Where to go next? This is just basically your end of deck set of slides. If you like books, you can buy mine. It's pretty much the only thing on the topic. I'm not doing that as a plug. I haven't gotten money from that book in 5 years, but it is a good resource. You can also check out my blog. I've got a bunch of entries. Again, not particularly recent ones, but they are useful for sort of exercising the weird extents of where extensions can go. Use a source, obviously. Pickle's full of very interesting things. And I say very interesting things, listing things like runkit and operator, which do things you probably shouldn't be doing. But PHP's API is very versatile. The internals list is a good thing to read at least, just so you know what's going on, what's coming up in the language. I'll get shot for saying this, but you can also participate in the discussions and throw in your 2 cents. You're welcome to bug me on Twitter anytime you want. That's my Twitter ID. And that's all I've got. So any questions on that whole thing? Can't believe we hit time like almost perfectly there. Like a boss. If there's a hand back there, just start shouting because I can't see anything. No questions. Okay, awesome. I accept gifts and beer and can be applied for any information you want. And have a nice time.